Welcome viewers to my channel. Today our problem is about soap bubbles. Our first problem is calculate the amount of charge required to expand the radius of a soap bubble twice of its initial radius. Okay, so you have a soap bubble of radius A. Okay, it is uncharged. So what is the internal pressure? We know that the internal pressure due to atmospheric pressure and due to the surface tension. Okay, so the internal pressure Pi due to atmospheric pressure P plus pressure due to surface tension. So that is equal to P plus 4T by A. We know the internal pressure expression Pi is equal to P plus 4T by A. Again, we know that the internal pressure is inversely proportional to its volume. Okay, so P is equal to some constant by V, that is equal to some constant by AQ. So pressure, internal pressure is equal to K by AQ. So we can say that the P plus 4T by A is equal to K by AQ. And now if the sphere is charged, then there is an electrostatic force acting outward direction. So there is also an electrostatic pressure P.Es. Electrostatic pressure acts outward. Okay, we know that for a charged sheet, the electrostatic force E near a point is equal to sigma by 2 epsilon 0. So electrostatic field intensity near a charged sheet is equal to sigma by 2 epsilon 0, where sigma is the surface charge density. So what is the force, electrostatic force? F is equal to, we know that F is equal to Q into E. So what is the electrostatic pressure? Pes is equal to QE by A. So that is equal to A is area. Okay, so Q by A, charge by area, that is equal to surface charge density. So sigma into E. So pressure, electrostatic pressure is equal to sigma square by 2 epsilon 0. We put the value of E from here. Okay, so if we charge the soap bubble, then the total internal pressure becomes P plus, as in this case the soap bubble become twice. Okay, so P plus 4T by 2A minus sigma square by 2 epsilon 0. This is the total internal pressure. Why negative sign? Because it acts outward direction, and P plus 4T by 2A, this pressure acts internal direction. Okay, so for the charged soap bubble, and this is for the uncharged soap bubble. So again Pi, we know that Pi is proportional to 1 by V, so that is equal to K by 2A whole cube. Okay, so we have P plus 4T by 2A is equal to 1 by 8 K by AQ. Again we have the value for K by AQ. We have the value for K by AQ, that is equal to P plus 4T by A. So that is equal to, okay, here P plus 4T by 2A minus sigma square by 2 epsilon 0. Okay, that is equal to 1 by 8 of P plus 40 by A. Okay. So from here we can calculate sigma. Okay. So P plus 40 by 2A minus sigma square by 2A to epsilon 0 minus sigma square by 2 epsilon 0 is equal to 1 by 8 P plus 40 by A. Okay. So 8P plus 16T by A minus 4 sigma square by epsilon 0 is equal to, as we multiply the 8, is equal to P plus 40 by A. So 8P and P, so that is equal to 7P. 16T by A, 40 by A plus 12T by A is equal to 4 sigma square by epsilon 0. Okay. So now I am going to calculate the value of sigma. So sigma square is equal to epsilon 0 by 4 7P plus 12T by A. So sigma is equal to half of root under epsilon 0 by A 7AP plus 12T. Okay. So this is our surface charge density expression. So now I am going to calculate the amount of charge required to expand the radius of soap bubble twice. Okay. So that we have to calculate the charge sigma. We know that the surface charge density Q is equal to, sigma is equal to charge by area. In this case the area becomes sigma by 4 pi 2A whole square, because the radius become twice of the initial. So that is equal to, so Q is equal to sigma into 4 pi into 4 A square. Okay. Now we have the value of sigma, that is equal to half of root under epsilon 0 by A 7AP plus 12T into 4 A square into 4 pi into 4 pi. So that's become 8 pi is to 8 pi A square root under epsilon 0 by A 7AP plus 12T. So that is equal to 8 pi root under AQ epsilon 0 7AP plus 12T. So that is the charge required to expand the radius twice of its initial. In our next problem, if a soap bubble is charged, calculate the change in radius of the bubble. Okay, we know that the internal pressure is inversely proportional to its volume. So we can write that pressure P is equal to K by AQ. Okay, so the pressure is changes with respect to its radius. So dP by dA is equal to minus 3K by A to the power 4, minus 3K by A to the power 4. that is equal to minus 3 by a into k by aq. So that is equal to minus 3 by a into p. So minus 3p by a. So dA is equal to minus a dp by 3p. Okay. Again we have minus dp is equal to sigma square by 2 epsilon 0. We have calculated in the previous case. Okay. So minus a by 3p into dp is equal to minus dp is equal to sigma square by 2 epsilon 0. So what is the value of sigma? Sigma is equal to e by 3p. Sigma is equal to q by 4 pi a square, so whole square by 2 epsilon 0. So that is equal to change in radius. So dA, change in radius, becomes q square by 96 epsilon 0 p pi square a cube. This is the change in radius.